Hi, welcome to Math After Hours with Miss Austin. I'm a licensed math teacher here to help you with your math questions. And today we're looking at the process of completing the square. Completing the square can help you solve a quadratic, but it can also be used to put a quadratic in vertex form, which makes it easier to graph a parabola. And we're going to be looking at completing the square today for vertex form specifically, but I'll also talk a little bit about how you would use it to solve. So we're going to look at a basic example first. We have f of x equals x squared minus 8x plus 10. The very first thing you always want to do is move your constant to the other side of the equation. And that's not something you're used to because we have this f of x here, we have function notation, but you still can subtract that constant to the other side. That's just fine. So this is what we have now. Now what I want you to do next is on both the left and the right hand side of the equation, I want you to just write a space like this. Because this is where we're going to fill in the number to complete the square. To figure out what that number is, you're going to take your linear coefficient, which is your number in front of your x, and you're going to divide it by 2 and square it. So negative 8 divided by 2 is negative 4, and then we square that, we get 16, and that's going to fill in both of these spots right here. So what you can do is on the left-hand side, we can combine these two numbers, and then on the right-hand side, we are going to factor. So on the left-hand side, we have negative 10 plus 16, which is a plus 6. Then on the right-hand side, we want to factor x squared minus 8x plus 16. So in other words, what two numbers multiply to 16 but add to a negative 8? Well, negative 4 and negative 4 multiply to positive 16 but add to a negative 8. And the reason why it's called completing the square is square has all the sides the same length. So at this point, when you're factoring, you should always get the same number twice. So negative 4 and negative 4. So this is x minus 4 times x minus 4. But we are going to write that as x minus 4 squared. So the last step to have this quadratic now in vertex form is to move your constant back to the other side. So we have f of x equals x minus 4 squared minus 6. What this tells you is this inside here is your horizontal shift, and it's the opposite direction of the sign. So this is telling you that when you're graphing your parabola, you would go right 4, and then this is your vertical shift, and you follow the direction of the sign, so you would go down 6. So right 4 and down 6 would give you a vertex at 4, negative 6. If you wanted to instead solve for x using this process, then that means if you're solving for x, y is equal to 0. So you would just replace f of x with 0 and solve for x. Okay, so we're going to do another example like that. So here we have y equals x squared minus 10x plus 1. So again, your very first step is to always move your constant to the other side. So we have y minus 1 equals x squared minus 10x. And this is the point when we prepare for completing the square. So I'm going to create that space on both sides of the equation. And to figure out what that number is that will go in those two spots, we will take the linear coefficient, negative 10, and divide it by 2 and square it. So negative 10 divided by 2 is negative 5, squared is 25. On the left-hand side, we simplify. So negative 1 plus 25, so that's y plus 24. And on the right-hand side, we want to factor this. So what two numbers multiply to positive 25 and add to negative 10? Well, negative 5 and negative 5. So that would factor to x minus 5 times x minus 5 or x minus 5 squared. And so once we move that constant back to the right side, so subtracting 24, we have our vertex form. That's x minus 5 squared minus 24. And once again, if you're wanting to solve for x, you can set y equal to 0, or if you're wanting to use this to graph, we have our vertex here. This is right 5 and down 24. Okay, so these were two pretty basic examples. What do you do if you have a leading coefficient other than 1? Well, I'm going to show you next. So with this example, we have a 2 out in front. So I think what we're used to is when we're factoring, we pull out that GCF, greatest common factor, very first. But when you're completing the square, you're actually not going to do that first. No matter what, you always move your constant to the other side first. So I'm going to add 50 to the left-hand side. So that's g of x plus 50 equals 2x squared plus 4x. Now that you've moved your constant, this is when we will pull out that leading coefficient on the right-hand side. But you're only going to pull out the coefficient, just the 2. And I know that these two terms right here also have an x in common, but you cannot pull out an x because then otherwise you will not have a quadratic that later we will factor. So it's just the leading coefficient 2 that we're going to pull out. So now, just like we did with the other problems, we're going to create that space on the left and the right side to complete the square. But on the right side, we need to put it in those parentheses. You'll take your linear coefficient in front of x, which is 2, divide it by 2, and square it. So 2 divided by 2 is 1, squared is 1. Here's where you have to be careful. If we look at the right-hand side, this is really 2x squared plus 4x plus 2. That's what we have if we multiply in this 2. And because of that, on the left-hand side, we're actually going to put a 2 here. So whenever you have this number that you've pulled out, you're going to multiply that by this first before you add it to the left. So we did 2 times 1, and that's where we got this 2 here. So this is g of x plus 52 equals, and then we want to factor this right here, this inside part. So what factors of 1 add to 2? Well, 1 and 1. So we'll still have the 2 in front, and then that factors to x plus 1 times x plus 1, or x plus 1 squared. So finally, we move our constant back to the right-hand side, so that's 2 times x plus 1 squared minus 52, and we have our vertex form. And again, you can set y, or g of x, equal to 0 if you're solving for x, and then we get our vertex from the inside and this number here. We would go left 1 and down 52. Okay, so we're just going to do one more example with a leading coefficient other than 1. Okay, this one also has a negative in front, but you're going to do it just like we did the last one. So we would take the constant to the other side first, so y minus 9 equals negative 3x squared minus 12x. Then at this point, this is when we pull out the leading coefficient on the right-hand side. So I'm going to factor out a negative 3, which leaves me with x squared plus 4x. I'm going to create my space on both the left and the right-hand side to complete the square. Make sure we do it inside the parentheses. Take your linear coefficient, that number in front of x, you're going to divide it by 2 and square it. So 4 divided by 2 is 2, squared is 4. But what do we add to the other side? Well, we pulled that negative 3 out. So really on this side, we have a negative 3x squared minus 12x minus 12. So we really should have a minus 12 on the left-hand side as well. So whatever we add to the inside here, make sure you multiply that by this negative 3 before we add it to the left side. Combining negative 9 and negative 12, that's y minus 21. And we have negative 3. And then we want to factor this right here. So what factors of 4 add to 4? 2 and 2. So it's x plus 2 times x plus 2, or x plus 2 squared. And finally, add your constant over. So we have y equals -3 times x plus 2 squared plus 21. And that is our vertex form. And that is the process of completing the square. Thank you for watching. If you have any math questions you would like me to do, please comment them below.